We are now going to demonstrate how JANA is conducting the verification, that is, checking the value in GIS against the source document and creating a permanent link to that document for traceability. This will provide Fortis BC with the understanding of what data is available and what documents exist, and the quality of those documents to support the data. GIS stores a large amount of pipeline data. This data is typically stored in an object table and will contain useful information for several important attributes. For example, a valve object in GIS will contain data such as the type of valve, size of the valve, and the data was installed. In this case, the valve is an object and the valve type, size, and install date are all attributes of that valve. Based on the data attributes in GIS and what is required for a quantitative risk assessment model, JANA has identified potentially over 300,000 relevant attribute data points. To verify such a large volume of data, it is critical that a controlled process be implemented for tracking the work itself and capturing the results. The GIS data analyst is assigned to verify the attributes of a certain object type, for example, attributes related to valves, over a certain span of the pipeline. We have organized the attribute data points that need to be verified into work orders. One of the most important features of the verification tool is that it matches the available documents to the object and attribute that is being verified and suggests the best of those documents to use for verification. An analyst first selects the line loop and the stationing range of interest. The analyst then selects the attribute type of interest. For the demonstration, we are going to use line loop CPH BUR 508, and we are going to limit the span of work orders to those between stationing 14,000 to 15,000. I am also going to select valve-related attributes. I happen to know, and for simplicity, that only one valve exists in this range. As you can see from the object ID, only one valve object appears in this search. However, there are several attributes to verify, each with a status of required, preferred, or optional. The data analyst can now prioritize the workload by focusing on required attributes, such as valve type. For demonstration purposes, we are going to select the valve type to verify for this valve object. In selecting one of these attribute work orders, the tool brings us to a new page. At the top of the page, information about the current work order is displayed. The middle of the page displays the current GIS data, including the stationing location and the attribute data. In this example, we can see that a plug valve was installed at a stationing of 14.8 kilometers along the pipeline. In order to verify if this is accurate, the data analyst needs to find supporting documentation that specifically mentions this valve and the type of valve. Based on the cataloging of the FileNet documents done on this line, the tool identifies and presents the most likely documents that fit the location and attribute type for this object. Only documents that apply to the same stationing range and contain valve information will be displayed. These are automatically sorted based on their quality ranking to ensure that the most reliable documents are used for verification. The GIS analyst must then review these documents to identify the best document with supporting information. By selecting the file name, the relevant document is opened to the correct page number based on the cataloging. Reading through the page, we find that a Nordstrom steel lubricated plug valve is mentioned. After the data analyst has reviewed all the relevant documents, they select the most reliable document to link for verification. Now, there can be several outcomes of the verification process. Successful verification, where the document and the GIS value match. In this case, the work order is complete and the system records the source document ID for traceability. A conflicting data situation, where the document differs from GIS or where a document contains information that can be used to replace a blank or unknown GIS value. This creates a ticket to update GIS. A situation where guidance is required, where additional guidance is needed to clarify the path to verification. A ticket is also created in this situation. And finally, no document found, where no suitable document was found to be used for verification. To continue with this demonstration, we will verify this work by selecting the first document as the document for linking, and we can push the Use Document for Verification button. This window shows two important sections. The As Found Values section, with the white background, summarizes what data is currently in GIS. The Attribute Verification section, with the blue background, is completed by the data analyst based on the data found in the supporting document. The data analyst can enter the reference value, select units if applicable, and specify if the document value is a match to GIS. The linear referencing section ensures that the location, or stationing, from the document is correct. In this case, a valve is a point object, so there is not an end chainage measurement. However, if the object spanned a range on the pipeline, such as a pipe casing, then this would be a check to ensure that the length of the object is a match. Finally, the data analyst can enter any comments from the verification. To repeat, if the verification was successful, meaning a source document is found that supports the GIS value, then the data analyst can select Verification Successful to complete the verification. The system records the data matched, and the document link is recorded. If there was a problem or discrepancy in the verification, such as a document with unknown location or a difference between the documented value and the GIS value, then a ticket is created. The ticket allows for further investigation by the JANA engineering team. This can result in recommendations to change incorrect values or update missing GIS values. In this example, the verification is successful. This process is repeated work order by work order until all attribute data points are verified. The data verification tool provides a systematic way of linking supporting documents to GIS data and therefore ensuring control, trackability, and quality within the process. All this verification and traceability data can then be uploaded to Fortis' system of choice.